If you make products with moving parts, here's a great new application that will help you answer two questions. First, what will the product look like when it's moving, and what are the kinematic properties such as distances, accelerations, and interferences? Previous videos showed how to create joints and define articulation. Now it's time to add motors to simulate this machine's operation. The goals are to simulate the gripper moving to a position on the conveyor, picking something up, and then moving it back. Using NX Animation Designer, let's first add a position motor to slide the transporter. You only need to enter values to control speed, duration, or distance. The system needs just two values and will compute the third. Here, we'll set the motor value to 1000 millimeters using the default duration. Another position motor will slide the carriage across the transporter, and another position motor will move the gripper up and down. Notice that we're only adding the initial motor sequence, and to get the return motion, we'll use a timeline and a handy mirror operation later. The last few motors will rotate the gripper, and a pair of position motors will activate the gripper fingers. Motor input can also account for accelerations, so if you want to simulate a ramp-up speed, it's just a matter of entering the desired parameters. Now that the motors are applied, let's see the results. Notice the instant playback performance. We didn't pay any attention to when each of the motors would operate, but we'll use a timeline to graphically adjust each operation. The timeline shows the duration bar for each motor event, and you can easily see when each event starts and stops. Recall we only define the forward movement, and a handy mirror operation will automatically create the return steps. You only need to select the desired motor events and choose mirror. The system creates the motor event, but in reverse order. Now it's just a matter of adjusting when each event will occur. We can select and drag single or multiple events or adjust the duration by dragging the endpoints. Snapping is available during a drag and guarantees that start and stop points happen at the exact same time. At any time, you can immediately see the results by hitting the play button. All component positions are computed based on the joint network and motor definition. Imagine being able to bring your product to life this fast and easy. Let's drag things around so you can get a feel for how easy Animation Designer is to use, and how a fast solver lets you test design alternatives in real time. Interaction with the timeline has video editor-like simplicity and performance, so you can easily control the sequence of operations. This combination of ease of use and performance lets us establish a very realistic motion of our machine in just a few minutes. Notice that each duration bar lists an event name. While we skipped over this step, a descriptive name like left finger squeeze will help identify what that event does. The gripper fingers need to rotate and release the part at the end of the return sequence. To accommodate this requirement, we'll simply drag those event bars to the desired timestamp. And a quick play validates the job was done correctly. If you need to speed up the machine's operation by having multiple motors move components at the same time, just drag the duration bars or modify the start and end times until they overlap. With this capability, you can have any number of operations happening at the same time. You can simulate complex machines, linkages and transmissions, and just about anything with moving parts. If you need to halt an event to leave time for an inspection operation, you can simply leave a gap between events. You can also use a handy split operation to create a dwell. We'll make some more adjustments to fine-tune our sequence of operations. Animation Designer includes two types of motors that can drive a joint continuously or intermittently, and both types can be applied to either a rotating or sliding joint. Even though this process is fast and easy, we can enable an option that will automatically compute the sequence during each event dragging, giving us a boost in productivity. With this option enabled, we can immediately see the positional changes as we adjust the duration bars. You can control when things stop or start by moving the timeline cursor to a desired spot on the timeline, then snapping events to it. Position solve happens so fast you can test design alternatives in less time. Now that we have our sequence of operation complete, we can analyze kinematic performance and look for collisions. We'll focus on that next time. Animation Designer is new in NX12 and is a perfect fit for designers that need to see their products in action and understand kinematic properties such as distances, velocities, and accelerations.